So welcome back to the next session of this P block elements 2. In this session, we are going to look into the preparatory method of the sulfuric acid, then followed by its physical and chemical properties, its uses. Then we are going to look into how to detect the presence of the sulfate in a compound. To begin with, the preparation of the sulfuric acid includes various processes: lead chamber process, cascade process, and the contact process. Out of these three processes, the contact process is given in the syllabus. In the contact process, very firstly, sulfur will be oxidized to the sulfur dioxide, and then sulfur dioxide is further oxidized to the sulfur trioxide. Then it is being treated with the water molecule and the 1 moles of the sulfuric acid to give the 2 moles of the sulfuric acid. The sulfuric acid that has been prepared by this method is almost 96 to 98% pure, which means 96 to 98% concentrated sulfuric acid will be able to get. So we'll look into the reaction. Very firstly, sulfur reacts with an oxygen to form sulfur dioxide. Then the sulfur dioxide that has been prepared, as we have discussed previously in the sulfur dioxide, this sulfur dioxide is a global warming gas, so it cannot be exposed to the atmosphere just like that. It has to be converted into the sulfuric acid. So the iron pyrite FeS2 reacts with an oxygen to form ferric oxide FeO, then sulfur dioxide. So to begin with, sulfur here it is 2. If I make it as 2 here, iron becomes 2. So to balance with, I will make it as 2 here. So 4, iron becomes 2. So 8 plus 2 is 10. So 5O2. So iron oxide will be getting. This is the various process that we have come across a term called roasting in the very first unit itself. Then the sulfur dioxide that has been formed will be treated with oxygen, which means further oxidized in the presence of vanadium pentoxide or platinized asbestos. Asbestos is the sheet that we use for the construction purpose and all. We have seen this asbestos as an example of a silicate in the unit 2. Okay. Then the sulfur dioxide is oxidized to sulfur dioxide. So to begin with, to balance it, so I'll make it as 2. So here it is 6. Equation is balanced. The sulfur trioxide that has been formed is treated with the sulfuric acid to form oleum. Oleum has a molecular formula H2S2O7. See, why we are preparing a sulfuric acid, but in the process we are again treating with the sulfuric acid before the preparation, which means we are preparing sulfuric acid from some other method. If I treat the 1 moles of sulfuric acid to the sulfur trioxide, we are getting 2 moles of the sulfuric acid as a product. So that's the purpose here. So that's why this is considered as an industrial preparation for the economical beneficial. See, this oleum that has been formed will be treated with the water molecule further to form sulfuric acid, H2SO4. So you'll be getting 2 moles of an H2SO4. Equation is completely balanced here. See, initially sulfur is oxidized to sulfur dioxide is oxidized to sulfur trioxide with the help of the vanadium pentoxide as platinized asbestos, and followed by it is treated with the sulfuric acid to prepare oleum. Oleum is further hydrolyzed to get 2 moles of the sulfuric acid. Then this whole reaction will be effective by maintaining a pressure of 2 bar pressure, and the temperature should be maintained at 720 Kelvin. As I said, this method of preparation produces the 96% pure sulfuric acid. So these are the conditions: 2 bar pressure, then 720 Kelvin. So you will be getting 96% pure sulfuric acid. Then regarding its physical properties, see, pure sulfuric acid will remain as a colorless, and it is a viscous liquid. Viscous in the sense is it has good viscosity because its density weighs about 1.84 grams per milliliter. So that's why it is quite viscous. And the boiling point and the viscosity of this sulfuric acid is because of its tendency to form a hydrogen bonding. So that's the reason it has an ability to form the hydrogen bonding because of the molecular association. It comes together. So that's the reason. So its freezing point is 283.4 Kelvin, then boils at 590 Kelvin. So this is regarding the basic physical properties. See, this sulfuric acid, regarding its solubility of sulfuric acid, this is quite highly soluble in the water, because we have seen this as an sulfuric acid shows highly viscous because of the formation of a hydrogen bonding. When it has a tendency to form a hydrogen bonding, it can form a hydrogen bonding with the water molecule. Thereby, 2 possibilities may happen. 1, it can dissolve in the water molecule. 2, it can form a hydrated compound with the water molecule. So we'll look into it. See, highly soluble in water, and because it can form hydrogen bonding, so it has a great affinity towards the water. then this sulfuric acid, since it has a great affinity towards the water, it can remove a water molecule from any other substance to which it is reacting. So I can take this sulfuric acid as a dehydrating agent. So that's the one. As I said previously, this sulfuric acid, when we are treating it with the water, it has two possibilities may happen. One, it can dissolve in this. It can dissolve with this water molecule. Two, it can form a hydrated compound. See, it has been stated. Sulfuric acid with the water molecule to form H2SO4.H2O monohydrate and H2SO4.2H2O dihydrate. So this is a reaction. The whole reaction, since it's a concentrated acid, when we are treating with the water, obviously the concentrated produces a large amount of an aid. So it's an exothermic reaction. So this is the physical properties. Then regarding its chemical properties, as I said, it is a dehydrating agent. Okay. Since it's a dehydrating agent, it has strong affinity towards the water. So it can remove the water molecule from any of the compound which is being reacting with it. See, the question may ask, show that sulfuric acid has a great affinity towards the water. You need to show that it's a dehydrating agent. Or directly it can be asked. Like show that sulfuric acid is an excellent dehydrating agent. So in such a way you can ask. You can, question can be asked, you can answer. See, this C12H22O11, it's very familiar. All this hydrogen and the oxygen over here. Here, if you treat this sulfuric acid with sulfuric acid, H and OH goes out, then remaining COOH is a byproduct over there. The next one, oxalic acid. Oxalic acid, COOH, this H and OH goes out, so carbon monoxide is a product, carbon dioxide is another product. So this is regarding the sulfuric acid acting as a dehydrating agent. Then decomposition reaction. See, sulfuric acid is quite stable to a particular temperature, after which it starts to decompose to give the sulfur trioxide. H2SO4 at high temperature gives sulfur trioxide plus water. So equation is balanced there. Then the question can be asked, show that sulfuric acid acts as a dibasic acid. Dibasic acid in the sense is, it has an ability to react with the 2 moles of the base in such a way, whether it's a Lewis base or we consider as a sodium hydroxide or potassium hydroxide, whatever it is. So 1 mole of sulfuric acid reacts with the 2 moles of the base. We'll look into it. Sulfuric acid reacts with sodium hydroxide NaOH to form sodium bisulfite, which is NaHSO4 plus H2O. So one of the hydrogen will take up the OH and goes as H2O. So this is sodium bisulfite. This reaction actually continues. See, from this reaction it shows that it has one replaceable hydrogen. When the reaction is being continued further, same, the sulfuric acid reacts with the sodium hydroxide. It forms sodium sulfate. Sodium sulfate is Na2SO4 plus H2O. So 2 H2O is here product. So Na2 is, so here it is 2. So 2 hydrogen will take up the 2 OH and goes as 2 H2O, then Na2SO4 is a product. So this clearly shows that this sulfuric acid is a dibasic acid. Then similarly, sulfuric acid, when it reacts with an ammonia, NH3, it forms ammonium sulfate, NH4 twice, SO4. See, 2 moles of an ammonia. We know that ammonia is an electron rich group and it acts as a Lewis base. Here, so the question can be asked, give a reaction to show that sulfuric acid has an ability to react with the Lewis base. So in such a way you have to choose this NH3. If just asked like show that sulfuric acid is a dibasic acid, you can write any of these two reactions. So this is regarding the sulfuric acid and its dibasicity. Next one, oxidizing property. This sulfuric acid has an oxidizing property because it produces a nascent oxygen. See, when sulfuric acid is decomposed, it produces sulfur dioxide, water, then followed by the nascent oxygen. Because of the formation of the nascent oxygen, it has an ability to act as an oxidizing agent. Carbon reacts with the sulfuric acid to form sulfur dioxide plus carbon dioxide plus water. So to check with the balancing, so oxygen, oxygen here it is 5, here it is 4. So I cannot do it. So oxygen turns 8, hydrogen becomes 4. Here if I make it as 4, then it is fine. Sulfur here it is 2. So oxygen 8, 4 plus 2, 6, 6 plus 2, 8. Carbon 1, oxygen, hydrogen 4. Equation is balanced. See, carbon here it is 0, the oxidation state is plus 4. So it has been oxidized here. So the next sulfur reacts with the sulfuric acid to form sulfur dioxide plus water. So to balance with, I'll make it as 2 here, I'll make it as 2 because even number has to be balanced. So then I need to check with the sulfur. Sulfur here it is 3, so it is 3. Oxygen 8, 6 plus 2, 8. Hydrogen 4. Equation is balanced. Then sulfur also here it is plus 0 oxidation state. There it is plus 4. It is very clear. Then phosphorus reacts with 10 moles of the sulfuric acid. You have to study in such. When phosphorus reacts with the 20 moles of the nitric acid, we have seen previously. Here this phosphorus has an ability to react with the sulfuric acid in the ratio of 1:10. So it forms phosphoric acid H3PO4. Then sulfur dioxide plus water. So phosphorus 4, so okay 4, hydrogen 20, 12 plus 4, 8 is 20, sulfur 10 here, so it is 10, oxygen 40, 16 plus 20, 36 plus 4 is 40, equation is balanced. The next one, hydrogen sulfide, H2S reacts with the sulfuric acid, form sulfur dioxide plus sulfur plus water. So to balance well, sulfur left side 2, right side 2, hydrogen 4 there, so I need to make it as 2, oxygen 4, there also it is 4, equation is balanced. Here hydrogen, sulfur minus 2 is oxidized 2 plus 4 and reduced to 0. The next one, here one of the SO4, here it is plus 6, okay, the oxidation state. Next one, hydrogen iodide Hi reacts with the sulfuric acid, it forms sulfur dioxide plus water plus iodine. So iodine 2, so I made it as 2, hydrogen becomes 4, so I need to make it as 2 here, oxygen is 4, fine, sulfur is 1, equation is balanced. The next one, here minus 1 is oxidized to 0, nuclear charge increases. Then HBr, the reaction goes the same way, HBr plus H2SO4 gives sulfur dioxide SO2 plus H2O plus Br2. The stoichiometry is quite same. So that's it with this. Okay. So these are all the possible reaction to show that sulfuric acid acts as an oxidizing agent. Next with the metal, it forms a salt. When a metal reacts with the sulfuric acid, it forms a salt. Look at here. Zinc reacts with the sulfuric acid to form zinc sulfate ZnSO4 by liberating this hydrogen. We have studied this reaction in the preparation of the hydrogen in the class 11. Okay, so that's a direct reaction. Then aluminium reacts with the sulfuric acid to form aluminium sulfate Al2SO4 thrice plus hydrogen. So here it is 3, aluminium here it is 2, hydrogen becomes 6 there, so it is 3H2. Equation is balanced. Then copper reacts with the concentrated sulfuric acid to form copper sulfate CuSO4 plus SO2 plus H2O. Okay, so to check with the balancing, sulfur there it is 2, so I need to make it as 2, hydrogen becomes 4, so I will make it as 2 here, oxygen 8, 4 plus 4, 8, equation is balanced there. The next one, reaction with the lead. Reaction with the lead actually includes the formation of the lead sulfate. I will write here Pb plus H2SO4 gives PbSO4 plus SO2 plus H2O. So to check with the balancing, sulfur there it is 2, here it is 1, I will make it as 2, hydrogen becomes 4, so I will make it as 2, oxygen 8, 4 plus 4, 8, equation is balanced. Then regarding the sulfuric acid, this sulfuric acid, not only the sulfuric acid, any of this mineral acid will not react with the noble metals directly. When I say noble metals, it inhibits its own reaction with the mineral acids. Okay, so the noble metals like gold, silver, platinum will not react with the noble metals directly. Okay, along with the combination of even if you look at the gold, it dissolves with the help of an aqua regia, not nitric acid and hydrochloric acid as a combination. So singly, none of the mineral acid will decompose or will dissolve the metals, will react with the metals. The next one, reaction with the salt. Okay, let's see it. Potassium chloride is a salt. When it reacts with the sulfuric acid, it forms potassium hydrogen sulfate, KHSO4. Then one of the hydrogen will take up the chlorine and goes as HCl. So this is the product. Similarly, potassium nitrate, KNO3. When I say nitrite, it is NO2. Nitrate, it is NO3. When I treat it with the sulfuric acid, it forms potassium hydrogen sulfate. So this is K, potassium hydrogen sulfate plus HCl. So reaction goes the same way. Okay, HNO3. Because nitrate, right? So HNO3 goes out. So this is your product. Okay, the next one. Then the other salts like the sodium carbonate. When sodium carbonate reacts with the sulfuric acid, it forms the sodium sulfate. Na2CO3 plus H2SO4 gives sodium sulfate Na2SO4 plus H2O plus CO2. So sodium balanced, sulfur 1 balanced, carbon 1 balanced, hydrogen 2 balanced, oxygen 7 balanced. The equation is balanced. Then reacts with the sodium, it forms, say the same sodium hydrogen sulfate it forms. So with the sulfuric acid, it forms NaHSO4 plus H2O plus SO2. So let's check the balancing. Okay. So NaHSO4 plus water plus bromine I have left, Br2. So Br2, so here it is 2, so I will make it as 2. Sulfur totally becomes 3. If I make it as 3, hydrogen becomes 6, so I will make it as 3 here. So oxygen 12, 8 plus 2, 10, 10 plus 3 is 30, it turns 13. So I have to double the stoichiometry further. If I double the stoichiometry further, if I make it as 6 here, hydrogen becomes 12, so I need to make it as 6 here. If I make it as 6 here, hydrogen becomes 12, then it is fine. Oxygen, I need to check with this. See, sulfur becomes 6 here. When sulfur becomes 6, I will make it as 4 here. I will make it as 2 here. So sodium becomes 4. So I will make it as 4 here. So bromine, I will make it as 2 here. Let's check with the balancing. 24, 16 plus 6, 22, 22 plus 24. So equation is balanced. Next one. Next one is reaction with an organic compound. See, it has an ability to act as a sulfonating agent with the benzene. So it forms a benzene sulfonic acid. C6H6 reacts with sulfuric acid. HOH can be written in this way. So this one of the hydrogen from the benzene will take up this OH and goes as H2O. Then the remaining product is C6H5SO3H. So benzene sulfonic acid. So this is the product. Then to show that its uses. It is used in the manufacture of the various fertilizers because sulfur is sulfur rich. So fertilizers, and used in the preparation of an ammonium sulfate, superphosphate, then hydrochloric acid, nitric acid, and this has since it has an ability to it has an affinity towards the water molecule, it acts as a drying agent, followed by it is used in the preparation of the various pigments. So these are all its uses, and various explosives can be prepared using this sulfuric acid regarding its uses. Then the important conduct is the test for a sulfate. If you have a sulfate in your compound, how to detect it? You have to treat with the sulfuric acid. Okay. You have to treat with the barium chloride. Barium chloride gives the formation. If we have a sulfate in our compound, you have to treat it with barium chloride. When barium chloride reacts with the compound containing sulfate, it forms a barium sulfate. White precipitate is formed. When there is a formation of the white precipitate, you can confirm the presence of the sulfate in the compound. See, barium chloride reacts with sulfuric acid to form barium sulfate plus HCl. So 2 of the hydrogen will take up the 2 of the chlorine and goes as 2 HCl. This barium sulfate that has been formed as a precipitate will give rise to the white precipitate. Similarly, lead acetate PbCH3COO twice reacts with sulfuric acid. It forms lead sulfate. Lead sulfate also gives the white precipitate here. Then similarly acetic acid, 2 molecules of CH3COO will take up this 2 molecules of nitrogen and form 2 molecules of CH3COOH. So this is quite important reaction. Okay, this is a reaction to show the presence of the sulfate in the sulfuric acid in a compound when it has been treated with the salts like a barium chloride and the lead acetate. So this is regarding. See, so totally in this video we have come across what is sulfuric acid, what is its preparation, and physical properties, chemical properties, uses, followed by how to detect the presence of the sulfate in the sulfuric acid. So here into the group 16. So in the next session we are going to look into the group 17, the tomorrow session. Thank you.